In this video, we're going to explore the scientific notation. So why does this notation exist? Well, think about astronomy for a moment, or astrophysics. You have planets that are massive in how big they are, how heavy they are, perhaps how far away they are from Earth. For example, and this is a rough estimate, the sun. So the sun in our solar system has a mass of approximately 1 times 10 to the 30 kilograms. Now, what does that even mean? Well, the short way of thinking about this is, let's think about what 10 to the power of 30 would be. It's 10 times 10 times 10 times 10. And I'm doing this a total of 30 times. So let's look at this. 10 times 10 is 100. 100 times 10 would be 1,000, and so on. It seems every time I multiply by 10, I'm adding another 0 to our digit. So 10 to the power of 30 would just be 1, 1, and then 30 zeros. I can't even write that all of this. It's not going to fit on the screen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 kilograms. Just to give you a sense of just how big the sun is, or how massive the sun is, that is how many kilograms the sun has of mass. I would not want to have to write this long number every single time I did a calculation involving the sun. So instead, we just use scientific notation, which in this case is 1 times that large amount. So even when we're not using incredibly massive numbers, you may sometimes still see scientific notation. So in this example, 3 times 10 to the power of 4 would just be 3 times 1 with 4 zeros. Now, you could use a calculator to do this, but let's just think about this for a moment. 3 times this number. All of these zeros are just going to stay zeros, but the 3 will be multiplied by the 1. So this makes 3 with 4 zeros. Final answer. It gets a little bit trickier when we get into decimals, but the most important thing is that we take note of the digit here in the units, so the digit that comes right before the decimal. So if we picture what this number is, it would be 4.5 times 10 to the power of 6, which is 1 0, 2 zeros, 3 zeros, 4, 5, 6 zeros. Now, the digit that's in the unit here will always take the place of the 1 in our 10 to the power of whatever the number is. So this number becomes a 4, and then the numbers following it will take the place of the zeros, or at least the first couple of zeros. In this case, the 5 would be the first 0, and now we have 5 zeros left to put. So it makes sense that this number would still be times 10 to the power of 6, because it's the first digit and then 6 numbers afterwards. And those numbers are either the decimals of our left number here, or if we run out of decimals, then zeros take their place. Here's another example. 3.712. Oops, 712 times 10 to the negative 4. Well, let's remember what happens when we have a negative exponent. It actually means we're multiplying by 1 divided by 10 to the power of 4. And 10 to the power of 4 is just 1, 0, 0, 0, 0, 1 with 4 zeros. What happens here? Well, 1 divided by 1 with 4 zeros is actually just 0.0001. A calculator can get that number, or you can realize that the 4 zeros are actually just here. 1, 2, 3, 4. Therefore, if you had a different one, like 10 to the power of negative 7, this would just be 1 0, 2 zeros, 3, 4, 5, 6, 7, and then a 1. So 1, 2, 3, 4, 5, 6, 7 zeros, and then the 1 comes afterwards. In this case, though, we only have 4, and the 1 before the decimal counts. Very important. And now, as per usual, our number on the left side, we look at the digit that's on the unit, or the, this digit right here, and that will always take the place of the 1. And then you just write the other numbers as necessary. So this becomes 0.00037112. Now, sometimes I see people trying to fit this number in here like this. So they start pushing it to the left, but that would be incorrect. You actually just start at the 1 and then you start writing to the right. You introduce more numbers if necessary. So this would be our final answer. This one's a bit of a backwards question. I'm asking, how do we write this in scientific notation? So 49,100. The strategy is always the same, where you take the first number and then you count how many digits there are after it. So first number and then 4 digits. So this would look like 4.91. I'll write the zeros for now, times 1 with 4 zeros. Now, these 2 zeros here are not necessary because they come after a decimal place. So we don't really need these. And this has 4 zeros in it. So 4.91 times 10 to the power of 4, because there are 4 zeros. And this would be our answer. Here's another one, and it's going in the other direction. So whenever you have very small numbers like this, same thing sort of, where you have to count all of the zeros this time. So 1, 2, 3, 4, 5 zeros. So we know for sure that we're dealing with a 10 to the power of negative 5. And then the number starts off with a 3. 3 point, the rest of these digits. So 3.215 times 10 to the minus 5. That about covers it for scientific notation, so I will see you in the next video.